When 4 astronauts splashed down in the Pacific Ocean after 10 days in space, they returned with a hard drive containing 12,000 raw photographs. These images represent a visual record of a journey that reached exactly 252,760 miles from Earth. For 5 decades, human spaceflight was focused exclusively on low Earth orbit. We mastered operations a few hundred miles above the surface, building space stations and relying on constant, immediate resupply from the ground. While these images circulated widely for their aesthetic value, they represent a collection of high-resolution data points used to verify spacecraft health in deep space. Moving 250,000 miles from the planet requires a reinforced technological architecture that behaves differently than anything in orbit. By analyzing the specific optical behavior playing out inside the camera's heavy lens, we can identify the physical forces acting on the spacecraft across 3 distinct mission phases. Examining the raw pixels verifies life support. Its radiation shielding and precise navigation functioned as intended while the crew was isolated beyond the reach of Earth. On the outward leg of the mission, the crew pointed their cameras back at the night side of Earth. With the sun positioned on the opposite side of our planet, the visible hemisphere is in darkness, except for city lights and cloud formations illuminated by sunlight bouncing off the moon. This is Earthshine. If you examine the extreme edge of the atmosphere in this long exposure, you can spot a faint glowing band of gas floating roughly 90 kilometers above the surface. This is the sodium line, a layer of ionized atoms left behind by vaporized meteors. Astronomers rely on this layer every night. To cancel out atmospheric blur, ground-based observatories fire powerful lasers into the sky to create an artificial star. Computers use that star to measure atmospheric distortion and deform telescope mirrors hundreds of times a second to bring deep space into sharp focus. Capturing this layer so clearly from a capsule hurtling toward the moon demonstrates the sensitivity of the new camera sensors and confirms their ability to record fine environmental details in deep space lighting conditions. That sensor sensitivity became critical a few days later when the capsule slipped behind the rugged far side of the moon and the crew recorded a total solar eclipse. Ground eclipses last minutes, but flying just 4,000 miles above the surface, the spacecraft spent 54 minutes passing through the moon's massive shadow. In that darkness, cameras captured a line of bright dots, the ecliptic plane, where planets like Venus, Mars, and Saturn orbit. If you look closer at the background of the photograph, you will find pure white, jagged dots that are actually physical artifacts. These are dead pixels. Outside the protective magnetic field of Earth, the sensitive camera equipment is constantly bombarded by high-energy cosmic radiation. When a stray cosmic ray hits the digital sensor, it permanently overloads the receptor, leaving physical scars on the hardware. These digital scars demonstrate the intensity of the radiation environment that the Orion capsule successfully shielded its human crew from during the mission. This high-speed flyby resulted in the most recognizable image of the mission, EarthSat. The blue globe appears to physically sink behind the lunar craters Integrity and Carroll. This is an illusion. The moon is tidally locked. From its surface, Earth never sets. This setting motion is created entirely by the spacecraft's high orbital velocity. A second illusion is scale. Telephoto lenses flatten the extreme distance, making Earth appear artificially large. This sequence documents the precise physics of the mission, capturing the capsule's high-speed orbital velocity as it pulls the background Earth behind the lunar limb. Verifying these deep space navigation maneuvers required the hardware to survive a violent return to Earth. This diver's incredible image shows the Orion capsule shortly after splashdown, its heat shield heavily charred from the violent re-entry. To manage the thermal load, the capsule followed a lofted entry trajectory. It plunged into the atmosphere at 25,000 miles per hour, subjecting the hull to 5,000-degree plasma to bleed off velocity while keeping the internal pressure spikes safe for the crew. The 12,000 photographs in the mission archive provide a granular record of the spacecraft's performance across 250,000 miles. These frames document the successful stress test of deep space navigation, of radiation shielding, and of life support. By withstanding the solar radiation that scarred its sensors and the plasma that charred its hull, this mission's hardware validated the engineering requirements for sustained operations beyond Earth. The mission archive confirms that the systems are now in place to support the multi-year journeys required for interplanetary travel.